Now let's write the code to initialize the BSS section. So the logic for the BSS section, initializing BSS section would be similar. It would be like for I equal to 0 to start of BSS plus I is less than end of BSS. We keep incrementing. We'll say BSS contents of SRAM, which is start BSS plus I equal to 0. So basically we will move from start of BSS to end of BSS, we will move zeros. And we will do it in assembly. We have branched to the loop clear BSS here. Loop clear BSS. Then we have we are loading R3 with end of BSS. Our end of BSS is defined here. Then the R2 is the end of data and our start of BSS. So R2 already has the start of BSS. So once the end of data section is the start of BSS section. So once we have gone through this loop, R2 already contains the start of BSS value. Now we compare R2 with R3 and then clear BSS. Now let's define the function clear BSS, which is we move 0 into R3, and then we store R3 in R2 and we add 4. So this is the 4 is like a post suffix addition. So we can take a look at the instructions here. Load and store. So here is a store. So in this we can have the number that is post indexed. There are pre-indexed, which we have both of them in brackets, square brackets. In post indexed, we have the post indexed increment value after the brackets. So here, this is pre-increment, this is post increment, this is out of the square brackets. So all these instructions have specific format, and we can look at the programmer's manual to figure out why things are done the way it is. And after finishing this, we will jump over to our reset is done. and we will jump over to the main program, the main C program. You can specify the size. Okay, let's save it. So now that we have written a preliminary linker script and a minimal assembly file to reset the system, let's try to compile it and see how it works.